Okay, problem 4 has this block of ice sliding down a frictionless ramp at an angle of 50 degrees, while an ice worker pulls up the ramp, or sorry, pulls on a rope. He's pulling uphill. It's kind of a strange, I'm not sure if this is a typo or if it's just sort of a strange way of phrasing things, but he pulls on the rope, pulling the block in an upward direction, but it's still sliding down, so he's just trying to sort of slow its fall, okay? And he puts on a force of 50 newtons. It slides down a distance 0.45 meters, and its kinetic energy increases by 85 joules. How much greater would its kinetic energy have been if the rope had not been attached to the block? So, what I've got here is the force is 50 newtons, the change in kinetic energy is 85 joules, and the distance is, 0.45 meters. So, here's the thing. As it's falling, we can say, it has some work done on it by the guy pulling the rope, right? So delta EK, well, so this change in kinetic energy is the total work done on it, okay? So there's work coming from several sources, and we can just add them up for the total work. The total work is, so there's W for the rope, and this is the work for the guy pulling on the rope. There's W due to gravity. There's no friction, right? I think they said. So frictionless ramp. So those are really our only two sources of work. So what we can do then is we can say delta EK was 85 joules equals work done by the rope plus work done by gravity. Okay, so now what was the work done by this guy pulling the rope? Well, he's pulling uphill, right? He's pulling up this way with FR, but the block is moving downward a distance d. So we have a constant force. So the way we compute the work is we compute F dot delta R, where delta R is your displacement, and he's displacing the rope. The block is displacing in the opposite direction of the force. So what this means is, our cosine of theta in the the F dot delta R is going to be -1. So the work is actually equal to negative F times D as he moves the distance D in this direction, pulling this way with a force F. So that's, let's see. So that's work rope of WR is negative 50 newtons. Well, it's negative 50 newtons times 0.45 meters. And so the work done by the rope, or by the guy pulling the rope, is going to be negative. It's going to be 22.5 joules. So that's 50 times right. Now, here's the thing. So this 85 joules equals the negative 22.5 joules plus work done by gravity. But here's the thing. They're asking how much more would the block's kinetic energy have been. Well, look, so we can solve this. Okay, so the work done by gravity was then, must have been 85 joules equals negative 22.5 joules from the rope. And then the work done by gravity would have been, must have been like 107.5 joules, right? To make the equation work. Okay, so this is the work done by gravity. Circled in blue is the work done by gravity. And then circled in red is the work done by the rope. Okay, now what they're asking is how much more would the block's kinetic energy be if the rope had not been attached to the block. So what they're saying is, look, what if this rope had not been there? How much more kinetic energy would it have? Well, in that case, the work done by the rope would be 0, obviously, because it's not there. So then the block would have gained kinetic energy solely due to the work done by gravity. And so its actual kinetic energy would be 107.5. But what they want to know is how much more does it gain with no rope than what it gained with the rope. So the difference is actually just the work the rope did, right? Or the negative of the work the rope did. So they're saying, here's the situation. The rope did negative 22.5 joules of work, or it took away, you could say it took away 22.5 joules of kinetic energy. That's really what it is. The rope is taking away kinetic energy the block would have. So how much kinetic energy did the rope take away? 22.5 joules. Well, if there had been no rope, then how much more kinetic energy would it have? Oh, 22.5 joules. So in this case, this is a situation where parsing the problem and understanding what they're asking, figuring out what they want, is almost harder than doing the actual math, because once you realize what it is, it's very easy. It's just the work done by the rope is what they're talking about. That's essentially what they want to know. So there's your answer.